Okay, so the function c of n equals 75 plus 30n, which gives us the cost c of a cell phone plan as a function of the number of phone lines n. In this situation, what information does the inverse tell us? So our inverse is all about the number of phone lines, right? So it tells us the inverse would tell us how much each phone line would cost given the um, total phone plan cost. Okay, so the inverse would tell us how much each phone line would cost given a total phone plan cost. Okay. Or, yeah, it would tell us how much n is, right? So all right, so we're going to write the equation. So I don't love this explanation because I like to think of it as, so I wrote over here without the c of n and just put it as c, like we're solving for n, the number of phone lines for the cost of the plan. Okay, so I mean, that's how I like to look at it. How much each phone line would cost, okay, that sort of means the same thing. Um, okay, so to find the inverse of this, I'm going to subtract, right, 75 from both sides. So minus 75, and when I subtract it, that cancels out. Okay, so now I have 30 n equals c minus 75, so I'm going to divide both sides by 30. Divided by 30, divided by 30. Okay, now just to show you, I am going to isolate n because 30 divided by 30 is just 1. Okay, so your answer for your inverse equation should be c minus 75 over 30 equals n. So now this says find the value of c6, show your reasoning, and explain what the values mean in this situation. So there's a couple of ways you can do this, all right? You can just substitute in, right, 6 for n. So I'll take this equation. I'm going to actually just take the original equation because it's not asking me what n equals, right? It's telling me n equals 6. Okay, what's the cost? And then it's telling me to explain the situation. Okay, so you can solve this the old-fashioned way. You can also go to y equals and put that in y equals and go to the table, and we're looking for 6. If you could see, I already had it set up. So I look when x is 6, the answer is 225. So in this case, c of n equals 225, right? 255. Another way you could have done it is using the store button. So you could have, okay, and you saw I did it above, but I'm going to show you again just so you see. 6 store x, and then we have 75 plus 30x, and that equals 255. Okay, so there are multiple ways you can do this. So show your reasoning and explain what the value means in the situation. So it means that the number of phone lines, right, for 6 phone lines is going to have a total cost of $225 plan. Okay, so when there's 6 phone lines, so for 6 phone lines, the plan will cost $255. Okay, so let's take a look at number 7. A local amusement park has an option for park goers to become part of a VIP program based on how many times they will attend the amusement park in a season. The VIP pass holder will be charged $75 per entry for the first 4 entries into the park. Every entry after will be free. Okay. The function T gives the total cost in dollars for the VIP pass holders to enter the park n times. Okay, so entries will be charged $75. Okay, so the first entry is 75. Then for 2 entries, it's going to be 150. I just think it's weird the way it's worded. Okay, for 4 entries, it's going to be 300. 75 times 4. Okay. And then for the 5th entry, right, every entry after will be free. So you'll have paid $300 in total the whole time. Okay. It's just a weird way to word that. But it is 75 plus 75, so it's the total amount that was paid. And I'm just going to make this okay, so it is a piecewise function because there are 2 rules or 2 conditionings happening here. So let's sketch it. This is actually, I did this earlier. This is actually the bring this up. Right, this is actually the rule, and it's not so 5 on is 300 when it's actually 4 on, right? And this is going to be less than 4. Okay. So I think it's a weird way to so 75n is the condition because it's 75 times n. Okay, and then for the next one it's just at 300. Okay, and this won't let me get rid of the bottom piece, so I'm just going to leave it there. This is all wrong from something else. So let me erase this if I can. Okay. So let's complete the graph. So we have 1 entry is $75. I'm going to make this dot bigger so that I don't have to. So 1 entry is $75. 2 entries is $150. 4 entries is $300. And then it's going to be for every entry after. It's going to be $300. Okay. I don't know how many times they're going to go to the amusement park. I'm just going to do 3 entries here. So it'll be 225. Okay. So as you can see, this would be your graph. And so what is the domain? Well, the domain is going to be, right, all whole numbers, or you could have put, right, all natural numbers, right? And you could even say n is equal to all whole numbers, okay? Or you could say n Okay, so n is all whole numbers greater than 0. Okay. Right, so because you can't really, well, I mean, you could enter the park 0 times, but that would just be $0, and that's not really a part of this scenario, but it can be done fine. Okay, the range. So your range is from $75 to $150. I mean, to $300. And you could say T, and I like using these little symbols. Okay, so in intervals. And you actually, there's so little numbers there, you could put 75 to, right, 150, 225, and 300. It doesn't go above 300.